Internet, I'm here once again. I decided, I don't know, to keep going with playing around with GitHub CoPilot. My last video was maybe a little more boring, unit testing. No one likes unit testing, even though everyone should do unit testing. That applies to me as well. I'm no better than the average programmer in that regard. But anyway, making a game, that's way more fun. And I thought this time I would try to do something more graphical. Last time I made like a Hangman game. And it was cool to see CoPilot draw an ASCII art Hangman. It's bananas. But I thought I would try and make a Go game, like a simple two-player Go. I won't have an AI. I don't think CoPilot AI is capable of playing Go. Although if it suggests an AI routine, maybe I don't think it's going to do that. I'm going to use Angular this time. I mean, I could have used Unity. I'm no good at Unity. I've used Unity very little. It would take me much longer to get anywhere. Another possibility was Monogame, which is the open source continuation of XNA. I have used that a lot. I'm pretty quick with that. But there's a lot of boilerplate that would just be kind of annoying. I mean, I guess I could do that all first. But with Angular as a web page, the stones are just circles. We can just do border radius 50% and stuff like that. So I think it'll go really quick. I think I can do this. If I can make Hangman in 45 minutes, I think I can do Go just as quickly. I do worry about counting the freedoms, but we'll see. Maybe CoPilot will do that too. So anyway, I built an empty Angular application here. It's running in the browser. It looks very interesting. There's nothing in here, and I've got the little server running here. I don't know, if you've never done Angular development, don't worry too much about it. There's going to be a lot of TypeScript and TypeScript. There's a T at the end of that word, and HTML, and TypeScript is just fancy JavaScript. If you want to think of it that way, it's fine. So I guess what I'm saying is if you know JavaScript, you'll figure out TypeScript, it'll be fine. So anyway, let's start making this thing. I'm just going to do a single component. Let me make the font a little bigger. Although I think, okay, so the first thing I want to do is have a representation of the board in memory, right? So board. I think I'm going to want two pieces of information. I'm going to want to know what color is on that space, if any, and I'm going to want to know how many freedoms. I think what I want to do is compute the freedoms with every click rather than, just kind of keep the board up to date. I think that's going to be better. But I don't know, maybe I'm wrong. Maybe I'll end up not doing that. So it's a 2D array. This will be my X and Y coordinate. And actually, for drawing purposes, because we're going to loop, I think it's actually going to be my Y and then X coordinate. But that doesn't matter. Okay, let me make a model. So I'll make a models folder for the tile. So I'm going to make the tile. And one thing to know about TypeScript, because it compiles down to JavaScript, thank you, that's not what I want. Whoops, AI. Interfaces are really good. Interfaces are your friend because interfaces dissolve away into nothingness. There's no such thing as an interface in JavaScript. But it gives you that IDE and also the compile time, if you want to call it that, the transpile time? I don't know. When it's compiling or transpiling from TypeScript to JavaScript, it will yell if you have, if you've said, hey, this is a tile, and the object doesn't match the definition. So you never have to actually implement one of these. You don't have any memory overhead or anything of a class if you just use an interface. But you still get all the great IDE and, again, compiler in air quotes support. So anyway, I'm going to do a color as a color or null, because there might be nothing there, and I'll have to make this color, it'll probably just be an enum. And yeah, freedoms as a number. And I think that's all I need. Right, it's angry because I don't have this color, so we'll make a color enum, export enum color. Let's try white and black. Enums also don't exist in JavaScript, but they are not transpiled away into nothing. It makes weird classes for them that are weird. Don't worry about it. Okay, so let's see if we, I don't know. I looked at once at what they look like, and they're bananas. So what happened here? I did say export enum color. So you should be able to find this. Add import. Okay, it just took it a sec for some reason. Okay, so now I think we can describe a board. Add import statement. Neat. And I'm going to want... Okay, so kind of similar to... well, I don't know. So I don't know what React is like. Similar to Blazor, which I've been using at work. In Angular, you don't want to do a lot of work in the constructor. You wait for the on initialized. Although, in this case, maybe it's okay. Well, no, we should be good and do it the way you're supposed to. So this is going to implement on init, which is an Angular thing, which is an interface also, which means it also compiles it down to nothing. And I think it's just ng on init. Oh, yeah, cool, thanks. All right, create board, sure. What do you think create board should look like? Ooh, you know what? Let's give it some hints. I don't think that CoPilot knows what we're building here, but if I call this application, and I don't want to just use the word Go, because I'm worried that, I mean, we can try. I'm kind of worried that it's going to say, oh, like the programming language Go? Ooh, maybe not. 19 by 19. That is the size of a Go board. I was wondering if I should say, like, the ancient game of Go, or, you know, something like that you see, but I think this will be fine. So we don't actually need to say new tile. Again, we won't instantiate one of those, but we can just do this, and we would say, I called it color, right? Color would be null, and freedoms would be 0. What's going on here? Null to type never. What's going on? Board, tile. What did I called it color and freedoms. Okay, I've done something wrong apparently. Number is not assigned to type never. What does that mean? This is an object. This is how you do objects. I don't think it's been a while since I did TypeScript. I don't think I need the quotes though. Yeah, what's just what's going on here? Ooh, okay, well here's a problem. So this is a tile. That'll probably, aha, okay, return board, great. It didn't know the type, which is interesting. Okay, return board is create board, that is fine. Let's now try and render this board. What's going on over here? Okay, I saw an error, but I think it just hadn't saved. I do have autosave on, right? Well, yeah, that was just a visual, VS Code thing. I'm pretty sure that Rider and IntelliJ in general just always autosaves. I don't know, whatever. It took a sec, I guess. Also, am I crazy, or is there like a space in this file name? Where's There is! How did I do that? Rename. This is fun. I'm already doing something horrible. Okay. And this probably has made things angry. Okay, it's figuring it out. Tile, good. I don't know why there's a red thing here, red squiggly underline. I think maybe that's what was freaking things out, is partially too. Okay, it's figured everything out. Okay, let's do a Go board. So I think a Go board is a table. You shouldn't use tables for layout, but I'm almost positive that it's literally a grid with rows and columns. So that's what I'm going to do. So this would be let row of board, and I'm going to want a Y, and there's like some sneaky extra Angular magic you do. Cool. I do want a button. I like to call, just because this course I happened to take on Udemy years ago for Angular, he always did his user event handlers prefixed with do, and I just got in that habit, and so I stick with it. So anyway, do click XY, that is what we want to do. And then I don't think I need to say anything here, but I do want to give it a class of either black or white based on the color value. Class equals, or class, usually I would do things like this. I'm just going to do this because that's what's making sense to me right now. So this would be cell.color equals color black. Seems a little gross to have to, there's probably a better way to do this and I just can't think about it because I'm quote unquote being watched right now. But I'm just going to do it because it doesn't matter super hard. And you know what, we get to learn a fun thing about Angular. On the views, you cannot access anything that isn't a public member variable of the, if you want to call it the code behind, that's what they'd call it in C# land. And that includes like enums and things. So if you want to get the enum into the view, this is the silly way to do it. Color, right? Are you? Oh gosh, I did call it color. Export enum color. So why are you having trouble? I promise this is the bizarre way to do it. Oh, here we go. Import color. Huh. TypeScript, I feel like it behaves a little different from Oh, and this isn't Writer, by the way. So this is PHP Storm. WebStorm would have been a better pick, but I happen to have PHP Storm. I don't want to say I used to do a lot of PHP development, because I kind of still do, but it's been a while. I don't know. I have a project for fun that's a website, and I use PHP and Symfony, and people have mixed feelings about PHP, which, I don't know. I share a lot of those mixed feelings. PHP is kind of a funky language. But anyway, PHP Storm is perfectly happy to do JavaScript and TypeScript and all those things, because I guess the assumption is if you're doing something in PHP, you probably also are doing HTML, and therefore JavaScript. So anyway, this is a weird thing. Again, an enum becomes like this weird object in JavaScript, and so you can assign the whole, enum type or whatever to a variable because it is an object. So you assign it to an object that is, it has to be a public member, and members are all public in TypeScript by default, which I'm pretty sure is different from at least C++. Wasn't it private by default? It's been a long, long time since I did C++. I'm used to thinking of private being default, and I don't know why. I don't know if that's because C# does it or C++ does it, and I just assume that automatically ever since. But anyway, that'll get it into the front, or into the view, so the view has access. Okay, the other thing to make it happy so we can start drawing this thing, I need to find this do-click function, and I'm not going to put anything in there yet, but this will be a number, and we'll do something. We'll kind of do that. Well, you know what, here, let's do current player as a color, and I believe black starts in Go. It's also been a long time since I played Go. So now what would you suggest? Ooh. If the color is null, then the color equals the current player. Get the freedoms. Yeah, that's true, right? Because you can't click on a space where there's already a color. You can't add a tile there. So that's really good. Okay, we're going to need a get freedoms method. That's not exactly what we want. Okay, let's save this for later. I want to start drawing this Go board. So this is not what I want, but it's very close in a way. So I'm just going to throw the CSS in here. So the table, that's our Go board. I'm not going to worry about putting classes or anything. Border collapse, yes. We'll say background color is like a brown, saddle brown? Sure, saddle brown can also be Go board brown. And then I'm going to want inside something to make like that plot, like a, so Go stones, I don't know if you've played Go, it kind of looks like a checkers board or chessboard or something without the black and white tiling. So never mind, I take it back. It looks nothing like one of those. The thing that I was trying to say though is it is a grid, but you don't place things inside the square. You put them on the intersections of the lines in Go. So I'm going to need those intersections in the middle. Maybe I'll just throw some like spans or divs or something and position them. I don't know. I'll figure it out. But for now, so a button will have a particular appearance, and if it's black, it will have something, and if it's white. So I set up this project, and when you create a new project in Angular, you can choose either plain old vanilla CSS, or you can be better. I don't even know why CSS is an option. You can be better and choose SCSS. And like TypeScript to JavaScript, SCSS just transpiles, or whatever you want to call it, down into plain old CSS. You can get yourself in some like minor trouble where you write rules that end up exploding in CSS, but by and large, it's great and fine, and also great, which I already said, but I'm saying it again for emphasis. So let's see, background color for Blackstone will be black, and background color will be white. I don't know why that time I typed less. These will be block, width will be an M, height will be an M, and this is where I was saying the border radius can be 50%. I could have also said 0.5 M, but whatever. Border, we don't want any border, and let's see if that's enough. I think we won't see anything. We kind of see something. Oh, they're all like, also, wow, they're so small. Is that really an EM? I'm not like zoomed in. I zoomed out here. Let's say also padding 0 and margin 0. I don't know if it would have had those by default buttons. Interesting. I mean, I clearly just need them bigger. Cursor pointer, because I want you to see that you can click. Okay. Unless it's black or white, then you shouldn't be able to click there, right? So I'll do like cursor, I don't want none. Was it default? I mean, really, it shouldn't be a button, arguably. if we're drawing a stone there. We should only have a button if we, I don't know. I'm not going to worry about it too hard. I'm trying to go quick. Okay, and this is too small. Let's try like 2em, 2em. Oh God, what have I done? Okay, that's looking bigger, and I want the background color to be transparent. Only if there is a stone would we draw it. Okay, I know what the problem is. This is looking like something though. The problem is, again, as a 2D array, when we're looping over it, as we are in HTML side, the first, right, when you go, I mean, this is true, I think, in C# or any language, 2D arrays, right? You're iterating through the first thing, the first column or whatever you want to call it. So what I'm saying is this should be YX, not XY, which is a little confusing. Okay, black, white, black, white. We're almost playing Go. All right, I want to make it look a little bit more like a Go board. I'm wondering if I can do any trickery. Like any trickery to put the cell. Like if I did the TD, if I did a before, I only have one before, and if I do an after? Let me see, let me try something, I'm gonna try something weird. Okay. Yeah, I'm gonna try something stupid. Okay. So we'll do a before. Yeah, let's just, so this is a virtual element or whatever they call it. So content, nothing, display block. On TDs, I'll do a position relative. So this would be position absolute. And let's do, this is the vertical line. So yeah, top 0, left 0. I'm going to want actually left to be 50%. And then height 100%, width 1 pixel. That'll be good. Background color white? I don't know. Let me... so that's going in front. But I think if I do... let's do this as position relative, and we can give it a z-index of 1, whereas we'll give this a z-index of 0. This is a little wacky, I'm going to be honest. Okay, so now we just have to do the other lines, and I'm hoping that I can do an after. So what I was thinking I was going to do initially was put a couple spans in here, like, or divs or whatever, and like have that one be the horizontal line and this one be the vertical line, something like that. I was like, man, I got to put a bunch of markup in every single cell. It's not really that bad, but I don't know, it's 19 times 19 of them. I don't know. You can argue whether or not what I'm doing here is a better or worse approach. I don't know which it is. Okay, so after content display block, so this would be top 50%, left 0, and a width. And let's see. Oh yeah, so sorry, so this will be a height of 1px then. Okay. Nice, nice, nice. Okay, so I don't think I like the color black though. Let's do like, yeah, I don't know, half opacity black or something. Yeah, it's a Go board. Okay, the outside shouldn't have like the lines on the edges here. We shouldn't be able to see, but do I want to? No, I'm not going to do it. I don't know. I'm thinking I could do something like first child, or I don't know, and then position them differently. And God, now that I say it, I have to try. Yeah, okay. So if the TD is a first child, then, oh, and this is the horizontal line, or the vertical line. Sorry, we want this for the horizontal line. If it's the first, so if it's the first in the row, then instead we'll do left 50% and width 50%. Let's see if that properly trims these on the side. I don't think, let me see. Maybe I have to do TD first child after, and then I can do this. Oops. Let me see. If this doesn't work, I'm just going to say never mind, because it's not that important. But it did work. Okay, I have to keep doing it then. So this, okay, so we're also gonna have TD last child. This is super, please don't, this is nonsense. Don't ever do this. Don't do what I'm doing. Width 50%, that's all we need. Okay, cool. So, and now we can do TD first child, TD before. Top 50%, height 50%. Oh, AI, you're figuring it out. You're gonna figure out the last child? Ha 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 ha, thank you. It looks more like a Go board. Okay, I'm glad I did that. That's wonderful. Okay, and there are also supposed to be dots at particular points in the board. A, I don't remember where they are. B, I've already wasted enough time trying to make this thing look like a more better Go board, so I'm stopping. I'm calling it here. I'm not doing more. We have a Go game, almost. So, let us make... God, it's tempting to do something else. Margin 0 auto. Can we do that? Does that center it? Oh, God. Width min content. Okay, I don't know. I just thought I'd center the board. It really doesn't matter. Okay, I need to stop this. I need to do the interesting parts. I need to make the Go game. Okay, so you place these stones. When you place a stone, we can count the freedoms of the current stone. That should be easy to calculate. Let's see what the AI will do. So this is not correct. I think we would start with a 4. We can do it either way. How do we... Yeah, it doesn't matter. If any adjacent cell, regardless of color, what I was trying to think about was like, does it matter if it's a friendly color or not? And it doesn't. So let's say color, or what do we want to say? Like get color equals null, then 1 else 0. That feels a little gross. Let me see if the AI is happy to complete these. It is. Don't do those. And now let's do get color. And it uses DX. Yeah, actually that's kind of weird. I don't need to do that whole DX thing. Let's just do it this way. Here, let's see if the AI is smart enough to do that. Sure is. Okay, I've got a bunch of silly lines at the end. Return null. Yep. Ooh, well, so this is a good point. Okay, so if you go off the edge of the board, then it's not a freedom. So let's say is free instead, or is tile free. Because yeah, when you're on the edge of the board, that's not a freedom. And we don't need the null check. We just want to know, is the tile free? So let's see what the AI... But there is also that if check that we need. So if, yes, thank you. Okay, AI help him out. I really need to let the AI help more. I'm doing too much stuff myself. So let me do something else for debugging purposes. I would like to show the number of the freedoms. I can just draw that inside the cell, or inside the button here. So here we can do cell freedoms, and right. Okay, so it's not updating as we delete them. Also, we can't see the color. Let's see, cell color equals null, then nothing else, the freedoms. We'll do that, and then I want to make the color be, I guess, red? I don't know. Color red, so we can see it. 4, 4, 2, that's accurate, but it needs to update also the adjacent cells. So I think what we want to do is, yeah, I guess for each, yeah, we just do it to the adjacent cells. We just update their freedoms, and that's it. That should be easy. So let's say, I guess we can just do this here, but I don't want to, I don't want to go off the edge of the board when I'm doing this. And I don't want to do a bunch of if checks in here. I don't do 4 if checks here. I'd rather just do something like, I don't know, compute freedoms and do x, y, and then I'm also going to do x, let's say +1, and then let's see if it figures it out. Yeah, cool. Okay, so I don't have to do that, and then we'll make compute freedoms. And we can say this way equals get freedoms. Okay, let's do that. 4, 3, haha! Tube 3, yeah, accurate. Okay, white goes here, black goes here, but this is okay. So now here's the point. I need to start deleting stones, but we would only delete a stone if its entire group has no freedoms. So either I can do that. I can say when a stone hits 0, we're going to have to like do some recursive look at adjacent, look at adjacent, look at adjacent. I don't think we want that. Instead, we would like to have the maximum, like your number of freedoms equals the maximum of yours and adjacent friends or something like that. So let's call this like this, I don't know, group freedoms maybe. I don't know if that's what I really want to call that. This is really weird. I don't know. There's probably a smarter way to do this algorithm, and I just don't know what it is. If x is greater than 0, and the color isn't the current player, that's not what we want. What I want to do, and we'll start with this, but what I want to say is if it's the current color, then your freedoms equals the maximum of your freedoms and the adjacent freedoms. Yes, that is correct. And you'll do it for x + 1, and you'll do it for y, and you'll do it for y + 1. Man, the AI. Oh no, wait. Oh no, this was supposed to be group freedoms. Sorry, this is group freedoms. Okay, that was the AI being a little funky. Okay, let's see what happens. So 4, 3, still 3. No, see, this isn't quite right, because I'm going to reduce them. It's not the minimum either, though. Man, how do you do this? What if I try asking the AI? Maybe there's a better way to do this. So rather than group freedoms, what if we say something like, let's try something else. Never mind this code. What if we say like recompute freedoms for every tile? What if we do the thing I said I didn't want to do? Because it kind of seems like I do need to compute freedoms. You don't know I've defined that. I mean, is that correct? I don't think that's correct, but that's what the AI wants to do. Is it? Do I just not know? Maybe I just don't know. Whoops. No, this isn't right. I mean, maybe, I don't know. I feel so, I'm like, oh man, I should like pause the video or something. Yeah, let me do that. I'm going to figure this out, and then I'll let you know when I have a solution. Sorry. I mean, for you, it'll be a moment, a mere instant. So I'm pausing right now. Okay. I think I realized the error in my ways. And actually, I was remembering back to a maze solving thing that we did like way back in, I don't know, because I've made a Go game a long time ago in college, and so I was like, how in the world would I have done it back then? And I don't know if this is how I did it back then, but thinking back to college, I remembered a maze solving algorithm in which you kept a list of all the tiles that existed in the maze initially, like a separate. So you had a group of a group for every tile where each group only contained that tile. And then as you joined the groups together, meaning that two tiles were touching, let me start over again. So when two tiles, you remove the wall between two tiles, then you merge those two groups. So now those two groups of one tile each became one group of two tiles. Is this making sense? This is horrible to try and explain. A picture would probably help. But anyway, in that way, you just keep connecting tiles on the maze, and when you only have one group left, you know that you have made a complete maze, and you have no loops, and you're guaranteed a path and all these things. So it's a really cool thing. So anyway, I think I can do something similar with stones, where I'll place stones down, and if when you place a stone it's adjacent to another friendly stone, then you'll just merge it into that group. And that group then can keep a sense of how many freedoms it has. That's what I'm going to try and do. I haven't thought it through to the very end, and it's possible that I'm wrong on this, but I don't know. I'm going to try it out. So, interesting. A group, I think I want a stone group as well. So let's say a stone group. So export enum, stone group. It really wants to call it model. I don't want it. So it is going to have a color. And, oh, God, sorry, it's not an enum. It's an interface. It is going to have a color. And then it's going to have a list of stones. But I guess what I'm going to say is tiles. And really what I want is like a coordinate. So yeah, we'll make a coordinate model. Interface, a coordinate, don't do that. And then a number and a number. Okay. Right, so what color is this group? What are all the coordinates? Oh, hey, I did the thing again. Come on, gosh, import. Okay, and then also I'm going to want to know the freedoms as a number. And I'd started adding something to each tile. I was having like personal freedoms and group freedoms as two things, and that's not what I want to do. So I'm going to rename this back to just freedoms on a tile. Although actually, I guess we don't need that. Actually, maybe this is where I could put a group. Like, what group are you in? I'm not going to worry about it. I think I'll get there some other way. I don't know. Maybe I'll end up revisiting that. But let's make this a stone group, not to be confused with a stone soup. That's a different thing. And then, yeah, we can just compute. Well, we're going to do something different. So let's compute freedoms. I don't even know. Let's say, I don't know, I might want this function. I don't need these. Okay, so what I want to do instead is when you place a stone, we need to do a couple things. Sorry, do collect. Okay, so we want to know if there are any groups in any adjacent tiles. And what that really means is there, like the first adjacent tile we have that has a friendly color in it, we'll just take that group and add ourselves to it. Ooh, but no, we can't do that because we might join two groups by placing one stone, in which case it is very important that we do so. So yeah, let's find the groups from this X and Y. And that's not what we want to do. Var groups. We'll call these like adjacent groups. So find adjacent groups. Let's say that. So, find group X plus 1. If group equal doesn't equal null, null push it, blah, 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 can't speak. Okay, that is what I'm going to want to do. So group equals that, if it's that. This is a little funky, but let's roll with it. Because I do need to find them. And then find group, I'm going to want to find that. Find a group. That would be null, agreed. And this is going to return, let's tell it. So this is either going to be a stone group or null. If the board doesn't have a color, then you're not in the group. Okay, the groups aren't indexed by XY. We need to go through all the groups. So maybe this is a reason why every tile should just know the group index it's in, but we're gonna have to change those. I'm gonna do it kind of the slow way at first because it's a very small board. I mean, 19 times 19, the computer can count to whatever that is, 100, and I don't even care. It'll count fast enough. So we'll say this groups find a group where the group has tiles in it, or right? What'd I say? Group, stone group. Yeah, it's got tiles. Okay, okay, tiles x equals x and tiles, yeah, find, or rather, group equals. Is this what I want to do? Sorry, I'm like, tiles any, where any tile x equals x and tile y equals y. And I might be getting my link. Tiles does not exist on stone group. Is that because I called it tiles with capital T? What the hell did I call it? Okay, tiles is a list of coordinates. That first is true. Oh, and stone group is an array of arrays. It doesn't need to be that anymore. It's just a straight up array because I was thinking, yeah, okay, yeah, it's just an array of groups. And then is it any or is it like some? Yeah, okay. Cool. What is group? Local group is redundant, agreed. Okay, so we would say find group is a group or null, so why are you complaining? Oh, undefined. Okay, so fine, we'll return or null. We'll null coalesce the undefined into a null, which is a little stupid, but that's fine. Yeah, I don't know why JavaScript has undefined and null. There's got to be some silly reason. I just don't know what it is. Okay, so we get the list of adjacent groups. Now here's the, and we want them to be, we want them to be adjacent. They don't need to be friendly because we also want to reduce the freedoms in that group. In each adjacent group, reduce the number of freedoms. Okay, I'm trying to think if this is going to work. I need a picture. Where's Paint? Okay, so you've got, this is fascinating to me. Okay, algorithms, oh my goodness. Okay, so we're going to have some sort of grid. Never mind the shit's uneven, doesn't matter. And there's going to be circles. Fill, solid color. I don't remember how you do this. Okay, here's a black stone, here's a black stone, and suppose we got more black stones. And then suppose we also have, we'll do light gray for the white stones. Yeah, that's fine. Okay, we also have some white stones or whatever. So I'm thinking I place a black one here. Let's count the freedoms. This group right now would have 1, 2, 3, 4 freedoms. This group would have 2 freedoms. When we place a black stone here, I think what I want to do is reduce the freedoms of each group first by 1. So we're saying this group, we're going to merge them in later, has 1 freedom because we've reduced it by 1 because we're adjacent to it. This group has 1 less, so it has 3. And now when we merge, and this group, this new group has 1. And then when we merge the groups, we sum, I guess we sum up their freedoms. That makes sense. So we reduce the freedoms of every adjacent group, And then for friendly groups, we merge them all together. And the freedoms is some of the freedoms. I think that's the algorithm. I think that's going to work. Did you enjoy my horrible MS Paint picture? I'm going to keep that open to remind me what I'm doing. Okay, so we find all the adjacent groups. For each of these, for each group, that's not how we do it. Let group in adjacent groups. Is this? Okay, again, sometimes my C# gets confused with other things. So group.freedoms minus minus. So I don't think that I put find adjacent groups. This returns a list of stone groups. Oh, it does have freedoms. Okay. So why don't you like freedoms? Does not exist on type string. I promise you it's not a string. It's a list of stone group. Is it of? Did I get confused? I'm sorry. It's of. I always get that confused. All the languages have to use a different word. Okay. We reduce the number of freedoms in all the groups. Fine. I want to do that first. And then I'm going to count my own freedoms. So var new group freedoms. And let's just make the new group. We'll just make the new group. We can just make them and we can merge them afterwards. I'm okay with, like, I don't know, if I want to be crazy efficient, I could say I'm going to like think about making the new group and not actually make it. I'll just make it. So this groups add, and this is going to be all of those things look accurate. So x, x, y, y, is that, hold on, that's not what goes in a group. Coordinates. It's trying to help me. Okay. Freedoms, we're going to have to compute those. Get freedoms x, y. It's not add, it's push. Okay, it doesn't like coordinates. Argument of type is not assignable to type stone group. Is it not? Don't need this. Stone group has color, tiles, and freedoms. Color, the current player, that's a color. Coordinate, and freedoms, a number. Tiles, aha, tiles. Okay, there we go. That's where the strong, again, so the typing is helping us, right? Even though interfaces don't actually exist, but the message is not the most clear to read. I'm being picky and adding spaces around my braces. Ooh, spaces around my braces. I didn't know it was going to rhyme. It was more exciting than it should have been. Property group freedoms does not exist. Right, so if I look at the board, I'm not going to easily see this now. I'm not going to worry about it. Okay, so I can't easily see what group these things are in, which is something of a problem. Because I would like to, I want to debug, so I want to see those numbers. So maybe I do make a group freedoms property, and I'll just I'll just do it stupidly, where I'll just go over every cell on the board, find the group, or I can go over the groups and then find the board. That's what we'll do. So okay. So anyway, but I'll just populate that data so we have it for this debugging purpose. Is this video going to take more than 45 minutes? It looks like it. That's not how I intended things to go. Okay, group freedoms. It's a number. Also, hard to say how much the AI has been helping me this time. It's been doing some stuff. 0. So at the end, after we've clicked, and let's make this be a little slightly tidier. God, is it Alt-Shift? Oh, I can use the middle click button. There we go, middle click button. Okay. Okay, so after I've pushed the group, so I'm still not done. So to do, I'm going to merge adjacent friendly groups. To do remove groups with 0 freedoms. You're very right about that, AI. It's so weird the things that AI caches up on. Okay, and then what I'm going to do right now, just so I can count the groups, and nothing's going to be merged, which is a little silly. Am I going to find that I don't need to merge them? No, I'm going to need to merge them because all the even the friendly things are going to say they have no freedoms. That's why we merge. But anyway, okay, so I want to see the number of freedoms. So I'm going to do for let group of all the groups on the whole of this groups. Yeah. And then for let tile of group tiles. Yeah, that's the one. Thank you, AI. Okay, so let's see. Okay, we're back to at least doing something. But, right, we're not getting the... I mean, it was showing a 0 before is the problem. That's the real problem. Like, this is going to show 0, but that's not true. So this is where we need to merge the things and sum up. So this would be 1, 2, 3, 4. That's accurate. So if we merge these groups together properly, we will have... yeah, we'll have something. We'll have something cool. So let's merge adjacent friendly groups. I'll remove this to do, and let's see if it knows how to do that. Come on, AI. Let me prompt it. For group and group, if group color equals the current player, we can do that in the adjacent groups. Let tile of group tiles, group freedoms equals group freedoms, not true splice. Fascinating. I don't actually know splice. I don't use splice, so I don't know. Okay, let tile of group tiles. So go through all the tiles, set the freedoms. Let's not do that. That's not what we want to do. Let's do new group equals, and we'll just always put things in the new group. Maybe that'll help to have that. Let's see what it suggests here. You don't need to do that. Okay, new group tiles equals new group tiles concat the group tiles. Sounds accurate. New group freedoms equals the group freedoms. Yep, we want to add them all together. And then this group splice, it wants to remove them. What we actually want to do is remove this group. So, okay, there's a better, if you can even call this an algorithm. If you know you're going to delete things from a list, you usually can't iterate through it. You'll cause problems. But you can count backwards, and that's a really good way to do it. So, for example, if you were counting 0, 1, 2, 3, and you're going to merge 0 into 1, you're going to shift everything to the right, right? So when you go to the next step in the group, is this making any sense? I'm terrible explaining these things. Okay, suppose you have a group or a list, and you've got A, B, and C, and you're iterating through them, and you're at A, and you're like, hey, I'm going to merge A and B together. So what you're going to end up is AB. Boop. Ooh, does it work in this case? When it wouldn't work is if you deleted. Because that's what we're going to do. That's the problem. So we're going to delete A. So what's going to happen is we're going to have B, C, and then you're going to advance in the list on what, you know, X++ or I++, and you'll have skipped B. That's the problem that's going to happen, is we're going to be deleting things as we go. So the way you can fix it is you count backwards. And that way, if I delete C and then go backwards, I haven't, you know, shifted everything down in the array. I don't know if that made sense. I don't know. It's a problem that seems to come up a lot. So we're going to have I equals adjacent groups count or length. Yep. I is greater than or equals 0, I minus. And then we actually need to go from -1. Okay, and then let's say var. Yeah, that thing. Okay, and then let's do this. So if the group color equals all these things, and then what we would do, we don't need to do this splice. This group splice groups. Oh, that's removing it. Index of group. Yeah, but we're looping through. So what we can actually do, we know what I is. We say splice. I'm pretty sure splice is to remove one. Method changes the contents of an array by removing or replacing existing elements. Start, delete, count. That's what we want to do. So we'll start from I and we'll delete one element. Oh my gosh, is this going to work? Okay, let's see what happens. 4, 3, accurate. 5. 1, 2, 3, 4, 5. 4. Oh, I did it wrong. That was 1, 2, 3. Now it's 1, 2, 3, 4. Yep. 3. Say black goes here. So this is having a problem, though. This should only be... We're supposed to be reducing the freedoms of adjacent groups, whether they are friendly or not. So what's happening there? Why does this think it still has 3 freedoms? Something weird has happened with that stone. This stone is behaving properly. Oops, I did it wrong. Yeah, look, it's happening again. What could be happening there? Ooh, wait, am I doing the X and Y stuff wrong? Because I need to... Okay, tile Y, tile X. Yeah, that's code that the AI wrote, but it is properly indexing Y first. Board Y. I feel like we're getting very close to having a Go game with some help from the AI. Let me check find adjacent groups. Maybe I did something wrong here. So we find group x plus 1, x minus 1, y plus 1, y minus 1. Else this bit. Return the group, find a group where it's tiles. Like, is it possible I've recorded the x and y coordinates incorrectly? I could put a, what would it be, like alt? I want to put like the x and y coordinates so I can see what it, but I want to know what it thinks its group, because I've got some duplicated information, right? And I'm afraid it's getting out of sync. We have this list of x, y coordinates, but you know, it could be that things are getting out of sync or something. 4, 3, 2, 2, 1. Why does everything appear to be working now? Is it when groups merge that things start to get weird? Yeah, look at that. I think my merging algorithm must be bad. Now we're just debugging. Is this what you joined for? Is this what you're watching for? Weird debugging? I almost wonder if I should split this video up. 52 minutes. All right. If it takes an hour, I'm just going to stop. And I don't know. I'll finish it up some other time. So new group tiles equals new group tiles concat. Okay, how does that work? Concat method used to merge 2 or more arrays. This method does not change the existing array, but instead returns a new array. Okay, but then we're assigning it to the new array. So we are doing it anyway. That's for the new group. And then, ooh, okay, here's a problem. Adjacent group length. That is not the index. We're removing from adjacent groups, but that's not what we want to do. We want to remove the actual group. Man, someone watching you probably saw that and have been infuriated ever since. So we want to remove delete index equals groups. Can I just find, or gosh, what is it? This is where like my C# is stronger than my TypeScript here, and this is just JavaScript. This isn't even TypeScript. But I want to find the index where it's equal. It's just index of, yeah, index of group. Yeah. Okay, let's see if that works. I should look. The AI knew. It told me what to do. Okay. So the problem seems to be when we were merging groups. So now, do we trust that everything's working? 7. Shouldn't have gone there. I'm going to take you. All right, so now what needs to happen is we need to delete the stones. And when we delete the stones in the group, every stone deleted is an additional freedom. Let me see, 1, 2, 3, 4, 5. But this stone is counting, so this freedom is counting double, which I don't think is how a human would count freedoms, but I think it's okay. So when I place a white, whose turn is it? Okay, when I place a white stone here, this should go down by 2. Yes. So that's not how it, when humans are counting freedoms, that's not how they would do it. But if the computer is counting them that way, and it's consistent, it's okay. And I think that's easier for me to program that way. So I'm happy with it counting freedoms that way. And why I was thinking that is like, suppose, oh, I've done this wrong. Okay, so when these black stones go away, suppose the white group here with 5, 1, 2, 3, 4, 5 was like that. When this stone goes away, it's going to add 2 freedoms to the group. But because of the way freedoms are being counted, like, yes, that's not how a human would do it, but again, it's going to work here. So I'm going to delete these 2 freedoms, or sorry, delete these 2, and then it will add a total of 3 freedoms to this group. A lot of freedom here, a lot of 2 freedoms here. And I think that's all going to be good. Okay, cool. Merge adjacent friendly groups. And then remove groups with 0 freedoms. Okay, this function is getting very large. I should break this up, but 55 minutes. Let's go. 56 minutes in. Yeah, 56. Okay. Sure, you can do it that way. So group. Yeah, you're trying to redefine them, and you know that's not unreasonable. So let's just say this. Remove groups with no freedoms. Let's break it out into functions. Remove groups with no freedoms. Okay, but the other thing we're going to want to do, so we're going to say this remove group remove stones in group. Yeah, I guess. Okay. Remove stones in group. Group, stone group. Oh, oops, I'm being too C-sharpy again. All right, so we do want to do that, but when we do that, we need to look at the adjacent. No, there's not another group. So we want to say, let's say increase group freedoms at tile X, tile Y. And it's possible, I don't think we care if we increase the current group's freedoms when we do that. That doesn't really matter. So I'm not even going to exclude them. We'll just count them up. We'll count them, yeah. We'll just increase their freedoms as we delete stones. Like, it's going to be a nonsense result in memory for a brief moment. It doesn't matter. So we find the adjacent groups, we go through all the groups, and we increase the freedoms by 1. That's what we want to do. Thank you, AI. Let's see what happens. Black, white, black, white, black, white. 4, 4, 4, 3. Oh my God, is it go, you guys? So I guess the other thing that we would need to do, 1, 2, 3, 4, 5, 6. When black plays there, it instantly goes away. Ooh, wait, is this really 13? That was a fun case. 1, 2, because of how it counts. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I think it's working. Okay, the only thing I want to do, 58 minutes and a half. I've got time. I want to count up how many stones are captured by each player. So I'll just do, black captures and white captures. And actually, I don't need to define the type. It's kind of like a C# saying var. It'll find out. It says, oh, it's an integer, therefore it's an integer. I don't have to say number. JavaScript is extra fun with its numbers, though. So when we remove a tile, when we do that, oh, I passed it over. Remove stones in group. So let's do this. If group color equals color white, then black captures plus equal. Do you know what to do? That's the thing to do. And then else white captures. Cool. And then we can show that on the front, or not on the front, on the view, whatever. Sure, I'll just say captures. Let's put it in H4. I don't know. definition list. White. I don't know if that's the best tag to use in this instance, but whatever. White captures and black. Black capture. Oh, wait. Captures? Did I not? For real? White captures. Which makes the back end unhappy. That's incredible that the AI, again, it saw this. Okay, anyway, so, okay. Black. Oh, whoops. White, and white. Oh, yeah, I've rewarded them the wrong way. It's that black has lost 2 stones, so white has gained the captures. Where was that? If the color was, if the group color is white, then black has captured things. Wait, did I confuse myself? Yeah, no, I did that right. Captures. If the color is white, then black is the one that has gained. Wait, what am I doing wrong? Am I seeing something backwards? I don't know. Well, you know, it's been an hour and a minute, and whatever the bug is, it's something stupid and simple, and it doesn't matter. So, look, I made Go. We would remove the debugging information, and the other, you know, huge missing thing that I knew I wasn't going to tackle going into this was the scoring at the end. So you would take every captured stone. Well, I don't know. Maybe this is probably the silly kid way to do it. But you take every stone that you have captured and you place it into territory that belongs to the opponent, right? So you're filling in their territory with the captures, and then you count up. But you could just count the territory and subtract the captures from the total. So I don't know. Anyway, I'm happy enough with this. I made something like a Go game. The AI helped an amount. I mean, honestly, the problem I was most hoping that it would be able to solve for me is this whole algorithm of, you know, counting up captures. And once you know, fair enough. I kind of had to get to start implementing the algorithm, then it could fill in the blanks. It wasn't able to, I don't know, create it whole cloth or whatever. I don't know. Which, I don't know, that's probably reasonable. But it was able to help with some things, so that was pretty cool. Anyway, there you go. Kind of Go. Made in an hour using GitHub's CoPilot. Yep, don't know when I'll post another video, but thank you for watching. If you have been watching, I hope this has been fun. I'll probably find some other silly video to do in the near future. So, you know, you can follow me or not. Do whatever your heart desires. Thank you very much. Goodbye.